Every 5 seconds, somewhere on Earth, a bolt of lightning rips across the sky. It's hotter than the surface of the sun and powerful enough to light up a whole town. But what actually causes it? I'm Mr. Sticklab, and today we'll find out exactly how a lightning bolt is born, step by step. And it all begins long before the flash, with something building silently, high above your head. Inside that towering thundercloud, powerful updrafts hurl water droplets and tiny ice crystals high up into the freezing top of the cloud, where they smash into heavier lumps of soft hail. Every collision strips away a little electric charge. The lighter, positively charged bits get carried up to the top of the cloud, while the heavier, negatively charged bits sink down to the bottom. So the cloud slowly splits in two, positive up high, and a great pile of negative charge gathering at its base. Now here's where it gets interesting. The ground beneath the storm is normally neutral, an equal mix of positive and negative charge sitting together. But remember, like charges repel each other. So the huge clump of negative charge at the base of the cloud pushes the negative charge in the ground down and away, deeper underground. That leaves the surface, and especially anything tall like trees, hills, and buildings, with mostly positive charge left behind. Now the negative cloud and the positive ground pull toward each other, building up an enormous voltage between them. The only thing in the way is the air, which is normally an excellent insulator. But that voltage keeps climbing higher and higher until it's finally strong enough to overcome the air's insulation and tear a path straight through it. So let's slow that bolt right down and watch what really happens. The air finally gives way, and a faint, branching channel of charge pushes its way down from the cloud in a series of rapid, jerky steps. This channel is called the stepped leader. As it nears the ground, a spark of positive charge leaps up to meet it, usually from the tallest object around. The very instant they touch, a complete path connects the cloud to the ground, and a colossal surge of charge comes roaring back up it. That surge is the return stroke, the blinding flash we actually see, racing upward at nearly a third of the speed of light. But what about the thunder? In a tiny fraction of a second, the bolt heats the air inside its channel to around 30,000 degrees Celsius. The air explodes violently outward, slamming into the air around it and sending out a powerful shock wave. That shock wave spreads through the sky as the rumble of thunder. Now light travels almost instantly, but sound is far, far slower. So we see the flash first and only hear the boom moments later. The longer the gap between them, the further away the lightning struck. And knowing how close that lightning is really matters, because a single bolt carries enough energy to be deadly. Lightning tends to strike the highest point around, so sheltering under a lone tall tree is one of the worst things you can do. If you're ever caught out in the open with no proper shelter, make yourself as small and as low as possible, and get indoors or into a car as quickly as you can. There's a simple rule worth remembering. When thunder roars, go indoors. So lightning is really just electricity on a giant scale. Colliding ice inside a storm splits the cloud into positive and negative charge. That charge pulls so hard on the ground that the air finally breaks down and a bolt connects the two, unleashing all that stored up energy in a single dazzling flash and a mighty crack of thunder. That's how lightning happens. I'm Mr. Sticklab. And remember, when thunder roars, go indoors. Stay curious, stay safe, and I'll catch you in the next one.